This first example gives us a mass of 8 kilograms, and it gives us a velocity of 20 meters per second, and it's asking for our kinetic energy. We know that our formula is going to be that our EK is half times mv squared, and we can plug in our numbers here. So we have half times 8 times 20 squared. We're going to get an answer of 1600 joules. If we look back, our significant digits are 2 and 2, so we need to give 1.6 times 10 to the, we had to move the decimal place 3 times, so times 10 to the 3 joules. This first question, it says that a ball is starting at position A and the ball's rolling to position B. And the first thing it says, how far does the ball roll? When we're looking at distance traveled, we always want to look at where it ended, and it ended over here at 25 meters, and it started at 0 meters. So we can say that we know for A that it ended at 25 meters, its final place, and it started at 0 meters. So we know that it traveled 25 meters, and that's the answer for A. B, it's saying what was the average speed of the ball. So we know that when we're looking for speed, we want to look for velocity. We know that our velocity is going to be distance divided by time. Another way that you can think about that is you know that the units here are going to be meters per second, and distance is a unit of meters and seconds is a unit of time. So we're always going to do the meters divided by the time. We know in this case that we went 25 meters in 15 seconds. And if we do 25 divided by 15, we are going to get 1.67 meters per second. This is already in the correct amount of significant digits because we needed 3, because it gave us 3 in the question. And for C, it's asking us for the kinetic energy, which means we're doing EK is going to be half mv squared. So we know that we have half. The question gives us the mass of 2 kilograms. And we just calculated our velocity of 1.67 meters per second, and we'll square that. The answer here is going to be 2.7889 joules. But in the question we were given 3 significant digits, which means we have to give back 2.79 joules. The third question is talking about an electron. It gave us the mass and it gave us the speed. In this case is the kinetic energy. We know that our formula is going to be EK is going to be half times mass times our velocity or speed squared. What we can do here is plug in our numbers. We know we have half. Our mass is 9.11 times 10 to the negative 31. When you're plugging this into your calculator, you need to use the times 10 to the button. Please ask me if you have questions about that, because you need to put an exponent there for the 10. We're going to multiply that by our velocity, which is 2.5 times 10 to the 8. And we have to square that. And then when we do our math here, we are going to get 2.8 times 10 to the negative 14 joules. This question is a little bit more difficult because of the numbers that you're putting in. So again, if you're struggling with your calculator, please let me know. This question is looking for mass. It gives you the velocity and it gives you the energy. It doesn't necessarily say whether it's kinetic energy or potential energy, but it does say that the bullet is moving. And when it's moving, we know that it has to be EK. So we have our EK. So in this case, we know that our EK is going to be half times mv squared, and we're looking for m this time, which means we need to rearrange our formula. When we're rearranging our formula, we need to get rid of v and get rid of the half. Another way you could do this is you could put your numbers in first. Before I put my numbers in, remember we can't use kilojoules, we have to transfer that into joules. So I can put my numbers in. On this side I have 2,000 joules. Over here I have half, and half is kind of just like dividing by 2. So I have mass there, and I know that I have my velocity, which is 3.0 times 10 to the 2 squared. Now that I have my numbers in, sometimes it's a little bit easier. Because what I can actually do is I can actually say, okay, I have 2,000 joules on that side, and on the right-hand side, I can do my... So here I have 1 time m, which is just the same as m. When I take this and I square it, what I'm going to get there is 90,000, and I can still say that that's divided by 2. The next thing I can do is I can actually say on this side I have 2,000 equals 45000 m, because I take my 90,000 and I divide it by 2. Now it's a little bit easier to rearrange. I have to divide both sides by 45,000, divide this side by 45,000. That 45,000 cancels out. Get my answer that my mass is equal to 0.044 kilograms. Because I want this to look like a more usable number, what I can do is I can change that into grams to say that it's equal to 44 grams. The question about the moving rocket gave us the mass, gave us the kinetic energy, but we do not have the velocity. So we know that our EK is going to be half mv squared, and this time we want to isolate for velocity. You can do it like I just did the last one by putting in the numbers first, or you can do it with the variables first. So if I'm doing it with the variables first, I'm going to divide both sides by half m and half m. And on the right hand side, the half m cancels out. So what I end up with here is I have EK over half m is going to be v squared. And to get rid of the squared sign, I have to take the square root of both sides. So I end up with the square root of my EK, which is 1.0 times 10 to the 3, divided by half times my mass, which is 2 times 10 to the 2, is going to be equal to my V. So in my calculator, what I would do here is I would put 1 times 10 to the third divided by 0.5 times 2 times 10 squared. And then when I get my answer there, I would take the square root of the entire thing. So my answer here is going to be 3.162 equals my velocity, and it's in meters per second. But what I need to do is I need to put that into significant digits. It gave me 2 and 3, which means I need to give back 2. So I'm going to say that 3.2 meters per second equals my velocity.